Okay, question number 35. An alternating current generator rotates 300 times in 60 seconds. 300 times in 60 seconds. Okay, let me start this. Okay, so which means when number of rotations in number of time is given to you, I can easily find out the ratio here. What does this ratio gives you? If I write the unit, you will get to know about this. 61s are 65s are, which should be 5 per second. What does it tell you? This is your 5 hertz, which is nothing but frequency. The frequency of rotation for the first one is known. Okay, and then the dashed line shows the induced EMF. Where is the time? Okay, which graph shows the induced EMF produced when the same generator rotates 400 times in 40 seconds. Now for this also we will find out, okay, the frequency. Frequency here should be 400 divided by 40, which should be 10 hertz. Okay, but what is that you need to find? Not the frequency. You need to find out what is the EMF over here. So when it was rotating like this, the EMF was so much. When it is rotating like this with a larger frequency, EMF, what is the value of the EMF? Does the EMF increase or decrease? That's what is the question. Now what we do is, what is the difference between the first and second one? Frequency is rising. See here we don't have frequency plot, here is the time plot. When frequency is rising, that means the time period should decrease, right? So therefore here the time should be 1 by 5 here, and here the time should be 1 by 10 over here. Okay, which means if F1 is lesser than F2, P1 should be greater than P2, inversely proportional, right? So therefore now as a result of it, P1 should be greater than P2. See here, so in this case P2, the solid line is a T2, right? T2 is larger than T1. Incorrect. Okay. T2, this is incorrect. Now let us look at this. Here also you see, this is T2. T2 is larger. Why do we say T2 is larger? Because you see, if I fulfill this one full loop, so this is only half loop here, right? One full loop will take this much amount of time. One full loop will take this much amount of time. Maybe here like this over here, or this bigger one. So definitely this time is larger than this time, right? So but what is that you need? You need T1 greater than T2. Therefore this is also incorrect. Let us look at this here. So here T1, the dotted line has a larger time as compared to solid line. So this is probably correct. Let us look at this array. This also shows me a similar one. See here, T1, the dotted line here. Look at this here. T1, the dotted line here is larger than this one over here. So this is also showing me a larger one over here. Okay. So now C and D could be the right answer, but which one is the right answer, that we need to look into it. Now once again, now why do we get an EMF? We get an EMF because there is a change in the flux. Now how do I calculate the flux from the given parameters? Now, what we do is, the flux is given by the formula NBA. Okay, so therefore I can calculate the EMF using E is equal to delta phi by delta T, which will now be equal to, now is B changing? B is not changing. A changing? A is also not changing. What is changing? N is changing over here. So therefore this should be delta N by delta T into BA. Okay, now what is the, let us plug in the values to find out what is the value of EMF. Now in the first case, what is EMF? E1? E1 should be delta N1 by delta T. What is delta N1? Delta N1 is 300 divided by 60. I substitute this 300 divided by 60 multiplied by BA, which should now be equal to 5 times BA. Second time, E2 is equal to 400 divided by 40 times BA is equal to 10 times BA. Now what's happening here? This E2 is greater than E1. Now let us look at this here. See, here E1 and E2 are same, but here you see E2 is 2 times that of the E1. See, E1 is having 1 box, E2 is having 2 boxes. So therefore C is incorrect, D is the right option.